Big thank you to all my patrons who support the Engineered Mind podcast. Hi and welcome to the Engineered Mind podcast. In this podcast, we cover topics such as engineering, artificial intelligence, neuroscience, and other interesting topics to educate, inspire, and engineer people's minds all around the world. I'm your host Joseph, and for this episode of the podcast, I'm very excited to welcome Eli Stevens, Luca Antiga, as well as Thomas Viehmann to my show. Luca Antiga has a Ph.D. in Bioengineering and worked in research until 2009. He is co-founder and CTO at Orobix, where they are busy taking artificial intelligence into the real world. Eli Stevens has spent the majority of his career working at startups in Silicon Valley, with roles ranging from software engineer to CTO. At Publication, he is working on machine learning in the autonomous vehicle industry. Thomas Viehmann is a Munich-based machine learning trainer and founded the boutique consultancy MathInf GmbH. He is one of the most prolific independent PyTorch contributors. His interests range from mathematical intuition and interpretation to the low-level details of making computation fast. He holds a Ph.D. in pen and paper mathematics from the University of Bonn. In this really interesting conversation, we talked about who should get the book Deep Learning with PyTorch, how important models are, why model deployment is so important, the well-known Imposter Syndrome, the very famous tutorial trap, and a lot of other interesting aspects about the AI journey in general. For updates on upcoming podcasts, projects, and videos, make sure to follow me on Twitter as well as on Instagram. To join my weekly newsletter engineeredmind.sh, where I share exclusive content, visit yusef.substack.com. And now, ladies and gentlemen, here's my podcast with the great guys Eli, Luca, and Thomas. So hey guys, it's really nice to have you on my podcast. We have 3 guys today in our show, and you might ask yourself, why 3 guys? Well, Thomas gives it away a bit because he has the cover of the Deep Learning book behind him. So what we start with is each of you gives an introduction to himself, and maybe we start with Eli, and then Luca, and then Thomas.
Hi, I'm Eli Stevens. I am currently a machine learning engineer in the automotive industry, and I'm one of the authors of Deep Learning with PyTorch. I'm excited to be talking about the book and PyTorch and all that kind of stuff today.
Awesome.
Hi, I'm Luca Antiga. I founded a company based in Italy, in Bergamo, where I live, called Orobix, and we do applied AI. And then I co-founded another company more recently called Tensorflow, where we develop open source core tech for AI development. And I'm a co-author of the book.
Great.
Yes, so I'm Thomas. I'm the 3rd co-author of the Deep Learning with PyTorch book. And I'm a mathematician by training, and I run a boutique machine learning and PyTorch consultancy and training company, MathInf, based in Munich.
Awesome. So let us start with... do you want to say anything else, Thomas? Sorry for interrupting.
Yeah, thanks for having us 3 here.
Sure, yeah. Absolutely. It's really nice to have you guys. What we want to start with is like the common question that always arises is PyTorch versus TensorFlow. It's like the big question, like the two big frameworks. Eli, do you want to maybe go a little bit into depth why you have chosen PyTorch and not TensorFlow? Because the book says Deep Learning with PyTorch, obviously.
Yeah. So one of the things that and this is kind of a dodge in some senses. One of the things that the founders of PyTorch have tried really hard to do is not turn it into an us versus them, like, you know, up with PyTorch, down with TensorFlow kind of a thing. I thought it was really interesting that Sumit Chintala talked about how the convergence of a lot of these frameworks, you know, eager mode and that kind of thing, was actually, he in his view, a loss for the deep learning community. He thought that having a wide variety of approaches and philosophies was healthy for the ecosystem. I personally was drawn to PyTorch because of its, I don't want to say simplicity, but it felt very natural coming from a Python background that didn't include explicit ML experience. The ramp into PyTorch felt very easy. It didn't feel like I had to learn a new way to think or a new way to code. I just showed up and started writing code, and it worked out great. So,
So you would say it's a more Pythonic way of actually approaching AI problems.
Yeah, it definitely seems to be and this is somewhat ironic for something that's based on an extension to Lua, but it definitely feels very Pythonic in terms of when you call a function, that function executes rather than it building a graph that'll execute later, kind of a thing. So,
yeah, that makes sense. Luca or Thomas, do you want to add anything here? Maybe Luca, if you want to go first.
Yeah, I started off with Torch 7, the predecessor of PyTorch, and I liked it because you could read the source code and figure out what was going on. It was very, very, very thin. It didn't have a real autograd, but it let you, as I was picking up deep learning in general, it would let you understand what was going on. And then I used TensorFlow for some time before PyTorch came out, and explored it a little bit. The error messages weren't great. I mean, it was certainly usable, and many people used it, and we were using it at the company. But then when PyTorch came out, we jumped on it because we kind of knew Torch 7. We still had Torch 7 projects going on. And finally, we could use the Python ecosystem. And at the beginning, it was really a Python layer on top of the same backend that Lua Torch had, plus the initial implementation of Autograd that was kind of coming from Chainer. And then it quickly evolved, but that initial period made me interested in contributing because I kind of know what was going on at the time. So it was very lucky for me to be able to take part in those initial stages. And again, yeah, as Eli said, it was great to have something that would fail at the line that you made a mistake and not at some point later on and you had to look through a big stack of errors. Now, of course, after some time, TensorFlow evolved with eager mode, so that now they look a lot like each other when you look at the code. But for the time, having execute as you go packaging, which you could even do autograd and stuff, was great. And it had all the modules that we needed at the time, like 3D convolutions and so on. So it felt a no-brainer.
Got it. Thomas?
Yes, so I can't say much about PyTorch versus TensorFlow because I've not used TensorFlow seriously for quite a few years now. But similar to Luca, I stumbled into PyTorch, and for me it was when PyTorch was quite new, 0.1 something, and somehow it was cool to do things, but then you always hit into something where you thought, well, yeah, this could be improved, and the people that were there in particular, I had lots of contacts with Adam Paschke, who's in Warsaw, and also the other people are based around the world. They were very nice, and so I ended up contributing a lot to PyTorch. Now I'm biased for the rest of my life.
I mean, it's nothing bad. Also, I have to mention, if people go to the PyTorch channel on YouTube, Thomas can be seen there. I think they recently also released a video with Thomas. So make sure to check it out, and I'll link it down in the description for sure. Talking about the book now, can you explain who is this book for? Is it more for beginners, intermediates, or even experts who want to use it as some kind of lookup table, if you want to call it like that, if they forget something. Maybe Eli again, if you want to speak about that.
So we definitely wanted to target the beginner to intermediate practitioner with the book. We started in part one, building up the basics from, expecting that a reader will have Python programming and linear algebra, and then implementing backpropagation by hand and that sort of thing, explaining the fundamentals of the Torch API. And then in part two, we transition into actually using that for I'm not going to say a real world project, but something that definitely is an advanced project at the hobbyist level. And so we were definitely trying to cover those people who wanted to do machine learning, but hadn't actually dove in yet or had gotten their feet wet and kind of wanted to take it further.
Mm-hmm. Luca?
Yeah, to me, the person I had in front when I was writing were people who didn't have too many problems understanding Python code, but at the same time, people that might have seen something but needed some more intuition behind the basic concept, so they could build a mental picture of what's going on, so that it would allow them to then tackle more complicated things later on. So I would say it's a book for, the first part is certainly for beginners or for people who do it, but they could still get something out of a few drills that we do. For example, what a tensor might be, or how backpropagation works, and so on, so that it solidifies their understanding. And then going into part two, then things become a bit more involved, but just because the problem is more involved. It's not like the moment you build the actual neural network is a small fraction of a project. And so part two is really balanced that way. I mean, it leads you through all the pain you had to go through, or fun, depending on how you interpret it. But really, you have to understand that those parts that are not, writing neural network architecture, but are, understanding data, reshaping data, writing data loaders, figuring out what is going on, why it's not convergent, and so on. These are the actual part of time, the most of the time that you will spend in any project, even professionally. So I think, I think the book gives you a honest perspective in that, and it goes in some depth in that process.
Mm-hmm. Yeah, got it. Thomas, you also worked on the last chapter, if I'm not completely wrong, which is regarding deployment. Do you want to talk about that? Why is it so important? And I've not seen any books, to be honest. I don't have too many, to be honest, but I have yours for sure. Why deployment is so important when you work with PyTorch or like any framework in general?
Yeah, well, we're building models mostly for fun, but then we also want to put them to work. And there's the gist of deployment. And so one thing about the book is that for timing reasons, we finalized the book some 11 months ago. And so at that point, torch serving, which might be the first thing that comes to mind for deployment because it's advertised on the PyTorch website, there wasn't a thing yet. But so like the broad range of problems you can apply deep learning to, you then have a similar spectrum of various deployment use cases. And so for us, it was important to also bring some perspectives there, not so much have a how-to like you would have in a blog post or something, but to really provide some intuition how the various things work, like how the JIT works and what the real advantages of using the JIT are, and also how you go with a model from Python to C++ or to mobile. And so we wanted to kind of provide the big picture that a person first jumping into getting a PyTorch model and taking it into production needs more than all the details that you could also get from tutorials like on the PyTorch website itself or some blog. And so this is really, I think, deployment really, it's a necessary step if you want to do anything serious with machine learning, obviously. And at the same time, it presents its own set of challenges. And really, I think this is something where the frameworks, and PyTorch included, will see some action at making it more user-friendly too. So, but the general intuitions that we provide there probably still apply afterwards. But it's an exciting thing, and really you need to know something. And as you said, there's not many things or not many texts or books covering it really end to end. And so we wanted to have that in our book because we really want to take the reader through a project from data to having something run where it could be like deployment.
Mm-hmm. Yeah, I think that's also one of... Yeah, Eli, please.
Well, I just wanted to make one thing clear also that, you know, while Thomas was certainly the primary author on the deployment chapter, his influence is going to be felt throughout the entire book. He definitely helped elevate both parts 1 and part 2. So I don't want to diminish his contribution at all there. So.
Oh, yeah.
That's nice input. Thanks. Of course, you guys have a lot of industry experience, I would say, from my standpoint, because I'm just seeing myself as a beginner. When it comes to the industry per se, Eli, do you want to talk about how important actually a model is? Because I think sometimes, especially when you delve into this field of AI or deep learning in particular, I think this is often overlooked or ignored. Let's put it that way.
Yeah, so that was definitely a misconception that I had when I started. You know, all of the research papers that are eking out another, 0.25% on some state-of-the-art benchmark, that kind of thing. It's all about the model. It's all about the model. And one of the things that I think Luca hinted at this earlier, but the book really tries to emphasize is that so much more is writing on making sure you get your data right, on making sure that you pick a problem that your model can solve rather than you pick a model that can solve your problem. All of those aspects are incredibly important to success. Even things as simple as making sure you're picking the right metric to look at to determine if you have achieved success is crucial. And I think that from the outside, it's really easy to lose sight of that sort of stuff. And you just think, oh, well, the key is to get the perfect model. That's really not the case. There are many, many problems out there that a very simple model is going to adequately solve if you have your data right, if you have your metrics right, if you're training in a way that makes sense. And so like Luca said, that's one of the things that part 2 really tries to do is emphasize it's not just the model, it's the entire project that matters. So hopefully that comes through, and hopefully people don't come away from it surprised that, oh, I can't just feed garbage unprocessed data in and have magic come out the other end.
Yeah, I think that makes absolute sense. Luca, before this meeting, we also talked about how important it also is to have this kind of research going on, like getting the last 0.25% of accuracy out of the model. How do you see that? like research plus industry, or like having like the synergy effect between academia and the industry?
Oh, for sure. It's essential that the research community goes after those percent, because out of those percent outcome, the breakthroughs, and not only those, the incremental improvements that, altogether make, something that was working 1 year ago, now make it, contribute to making it work a lot better. Mm-hmm. But at the same time, much of the research is done in a setting that is with a fixed data. It's a fixed data setting is not something that you find in the industry. Most of the time in the industry, you work with a variable data, and you are the one responsible for making your data rich, because you need to tell your counterpart, look, I need this data to make my model better. So please, collect this type of data, because this is what I need to succeed. So the absence of a strict boundary around your data makes the work in practice a little bit different from the work that you do as a researcher, like most of the time, because it's not nice to generalize, but let's say a Kaggle computation is a different set in the real world, because with a Kaggle computation, if you're forced to use that data set, you're given a data set, and then you have to go to make the most out of the data set. And this is just an example, of course. While in the real world, you start off with a data set that is not great, then you have to figure out what is the next step. So it's all very iterative. And sometimes it's not, sitting in your lab or office for a few months selecting the best model, but is applying the model you've been using and figure out what next you have to ask your counterpart so that your model can grow. This is the usual setting in which we operate.
Mm-hmm. Yeah. And I mean, asking Thomas now, I mean, with all the papers coming out, right? I mean, before this meeting, we also talked about intuition, that you have to develop this kind of intuition to decide what is right and what is wrong. What would you add to that?
So I think that's the key part, because really, if you have an intuition about how these things work, I mean, there's two things. There's one thing that if you want to adapt a model that's out there, and most often we want to do something like that, if you want to adapt an existing model to your problem case, you kind of have to have an intuition how things work. But also, if something fails, and we do follow some of the failures in the second part of the book, precisely for this reason that we can say, well, now something failed, and now you need to have kind of an intuition as to what is the matter, why does it fail? For example, when we do the, and I don't know if we mentioned it, so we detect nodules in the lung in the second part. And so this comes with a segmentation model at some stage. And training it will fail if you just throw entire CTs at the problem, at the network. And that's and then you need the intuition. Well, yeah, what we're trying to solve here is a pixel by pixel classification problem that is very imbalanced. And if once you have this imbalanced intuition, you can say, well, yeah, what are we going to do? Well, we're going to show more nodules than other tissue. And then you solve this class imbalance problem. And once you've seen that it's a class imbalance problem, it's really easy to know what's the right thing to do, but you need this intuition. And so to me, and maybe that's also because I'm from a mathematics background, this intuition really is the key thing that I'm after, and probably also one of the things that I have to offer when I'm working with other people on a project.
Mm-hmm. Yeah, talking about projects. Yeah, Thomas, please go on.
Yeah, and so that's kind of one of the things that I think that the book format is good for. And so some people ask us, well, yeah, why are you even writing a book? But I think for building this intuition, both in the first part, the intuition for the various parts and ingredients that you need, from data representation to how the neural networks work and how the learning process works, to what happens if something goes wrong and how can we assess what went wrong, that we do in part 2 for our concrete project. I think building this intuition really works a lot better over the book length than over tutorial lengths. And so, that's what my main take here is, that what one needs to succeed.
Mm-hmm. Especially when it comes to books, ebooks, or projects in particular. Maybe the question goes to Eli. Some people get stuck in this tutorial trap, and we talked about this actually to start and not to procrastinate. Or I'm doing like 5 more courses on the internet and then I will start doing a project. How do you see this problem, or how would you approach it personally?
I mean, I definitely think that there is value to taking courses, reading books, all of those sorts of things. The question you have to ask yourself, what is the best use of your time at any point? If you haven't done any tutorials or read any books, absolutely. I think reading can definitely help. That's why I wrote a book. But I think that at some point you have to transition to being a consumer and actually start working on something, picking a project that's yours. I think will once you've gotten over that, okay, what does the API look like stage? Like once you've gotten over that hump, actually having a project that you're interested in, you're invested in, and doesn't have everything mapped out for you is super important, because that's when you really start to see what it's like and be able to actually exercise those thought processes that will lead to the intuition that Thomas is talking about yourself. And I think that's crucial. You have to learn by doing at some point. And so, there's a balance to be found there. But I think that it can be easy to treat taking another class or reading another blog or reading another book as a procrastination technique. Mm-hmm. And so you have to ask yourself, do I actually need more training or do I need more experience? And obviously that's a question that every single person is going to have to answer themselves.
Mm-hmm. Yeah. Highly related to that is the so-called imposter syndrome. I know my audience probably gets a bit tired because I talk about this every second podcast, but I'm always interested on what people from different fields think about this. Luca, maybe you want to add your 2 cents here on the imposter syndrome?
Yeah. So I am very okay with feeling an imposter. I wouldn't say I have imposter syndrome. I would say I'm genuinely an imposter in almost everything I do. So I just learned to make peace with that, and you should be driven not by what you think people think about you, think of you, but the fact that everyone, even the most experienced people I've met, they are trying to, they're striving to be better, and they see all the limitations of what they have in their heads. And so I think, it's an act of self-defense, probably, finding yourself, lamenting imposter syndrome. I think you should train yourself to be okay with it. Mm-hmm. and move along. And of course, there's also a theme of, being in a sane environment that doesn't necessarily force people to feel like an imposter, right? So I think if you're in a toxic environment, then this thing might be exacerbated, not because of what you feel or how you feel about yourself, but also the inputs that you have. And, there are some lucky people, like I can say myself, who have never really, experienced pushback, and so I can relate the being an imposter only as a one-to-one thing at the mirror. But nobody ever said, shut up, you don't understand, or whatever, you're not entitled to speak. And so I think that might also play a big part. So we have to be very attentive to these mechanisms. But at the same time, I think, I would just reiterate what I said at the beginning. We have to make peace with the fact that we don't know.
Is it also maybe the nature of the beast, especially in AI, just because so much is published, that the more you know, the more you actually know that you don't know anything about the field. So it also humbles you in a way, right?
Well, but it's a good sign. I mean, it's a sign that you start understanding the vastness of things that you need to know, and so that you start understanding that you should focus on something specific and not try to cover everything, because otherwise it's like fishing, running after one fish and then you see another, you run after the other, and at the end you'll be starving. So.
Yeah. Well, what's your take on the imposter syndrome, Thomas?
Yeah. So I'm color skeptical. So I think you have to make, as Luca says, you have to make peace with who you are and what you can do well, and there will be things you do well, and what are the limitations. So for all the great things that the internet brought us, it also has brought us kind of a lot of self-display that is kind of exaggerated, and so I think there's an overconfidence epidemic, if you want. There's the mirror of, or the backdrop, where we then think about imposter syndrome and am I worthy and things like that. But in the end, there will be, I can without hesitating, both in machine learning and in mathematics, name 10 people I personally know who are just in a different league than me. And that's okay with me. And at the same time, there will be lots of people on the internet who will not hesitate to tell me I'm a complete fool, and I know who of us is. So, and people believe the wildest things, right, about themselves and also about others. That's unfortunate, and we see some of the worst on Twitter and other social media right now. But in the end, I think what Luca says is important. One thing is just be yourself, and don't always compare your true self against the image that others project of themselves, and that will go a long way, and also find a sane environment. So, for example, writing the book with Eli and Luca was such a positive experience, working with them. And similarly, I talk a lot with Piotr Bielecki from the PyTorch forums. He's the guy who answers like 40% of all PyTorch questions on the PyTorch discussion website. And there's no shortage of these people who are very positive. And if you're in an environment like that, you can do the things well that you can do well, and you can also be insecure about other things, and they will just help you out there. And so I think Lucas' advice is spot on here. And at the same time, I think it's something to not only think as a problem of oneself, but maybe also of how everyone presents themselves on the internet.
Mm-hmm. That's excellent advice. Yeah, Eli?
One thing I wanted to add also is, if you think about it, the number of people on the planet who have 10 years of experience doing deep learning is like this tiny handful of people, right? Like, and fundamentally, like nobody has 5 years of experience with PyTorch. Came out 4 years ago. And so, the thinking about the time delta, the investment delta between someone who's just starting and the bulk of the people who are doing this work today is like a couple years, which I'm not saying that's trivial, but when you're talking about, a software career that you plan on having last decades, a couple years isn't a whole lot, really. And so I think it's important to like Thomas and Luca said, is like, keep in mind that the people on the internet, they're not that far ahead of you. So dive in.
Right.
Yeah, I think that's excellent advice. Okay, one question I have for you guys is, which is a concept which fascinates you the most about AI in general? Maybe Eli, if you want to start. You did not have time to prepare this question, I know, but maybe from your gut feeling, what's the most exciting one?
Well, I'll say that you'd probably get a different answer every day that you ask me this question. Right now, one of the things I think I'm most interested by is some of the uncertainty around at a very like fundamental level why it works in the first place. There was a paper, the lottery ticket hypothesis, that says if you take a net, you can train it, find out which weights in that network are actually important for your final answer, zero out everything else, mask out training of everything else, go back to your original initialized weights, train your model again, and you get better results than you did, having thrown away like 90% of the computation that you're going to do. What is going on there?
Yeah,
What's like, and so I think it'll be really interesting as we are able to pull apart like the fundamentals of what it is that's going on under the hood. And I strongly suspect that in, I hope, a decade, we will have figured out ways to just start at that final 10% and not have to waste all of the computation and time training the 90% we don't need. So I think that's really interesting.
Luca?
Yeah, so I think from a fundamental standpoint, I'm pretty much fascinated by the same things, and some of the new like alternative architectures or methodologies like reservoir computing and stuff like that is really fascinating. But what I'm dealing with the most is the last stretch. So how do you get AI really, working in production, and what it takes to, when you finally have the first version of your network, what it takes to really rely on it to do something critical. So this is something I'm very interested in, even from a methodological perspective, and then I get passionate about the tooling. So all the things that gravitate around or make fundamental tools that could be used as a building block in the future. This building block thing is something I like to explore. Not necessarily I successfully deliver, but I'm really I would like eventually to build many building blocks that other people can use. That would fascinate me the most, probably.
Excellent. Thomas, let me guess, is yours the double descent topic, or is it something else?
Yeah, I just told you that I have I'm writing on a thing on it. But I'll go out here and say something not nice, and I'll say the lottery ticket hypothesis only says that we're really, really bad at initialization. And and it further says, well, yeah, even somebody who's bad at initialization, if he initializes enough, there will be some good parts. And that's the lottery ticket hypothesis in a nutshell. And of course, the good question that you want to ask is, well, yeah, which parts are good initialization? And I'm sure we'll make progress on that, and I'll be excited about it. And I think the lottery ticket hypothesis, it's a good result, and it's a neat hypothesis and interesting. I like to have these simple intuitions and one-liners that kind of summarize complicated theories. But so what really gets me going is when something actually happens. Like this background thing. I mean, it's not a big thing, and you have that in your Zoom app if you have the Zoom app, but I'm incredibly happy if I can build something like that by myself. So it's this is just a simple unit like the one we do in our book, and I trained it on a public dataset MS-Coco to detect persons in this picture, and then I hooked it up to the webcam and to fake webcam, and that's the result. And I'm really happy if I can build things that actually do something.
Mm-hmm. That's awesome. And instead of going in the circle and asking Eli again now, Thomas, maybe we go the other way around. We go with you first and then Luca and Eli, which is the question about accessibility of deep learning. How much do you think mathematics is actually needed? Because some courses say, you know it, right? There are courses or books out there, you don't need any mathematics. You can just type this line and then you have your wonderful network. How much mathematics is needed? And I mean, it's covered in your book, right? What are tensors? And then you go a bit into depth there. How do you see it from your perspective with a mathematics background, especially?
Well, so there have been people that say, well, yeah, our book can't be that serious because there's not enough formulas in that. But I think we have the right balance there between intuition and formulas. So I think mathematics and mathematical intuitions are probably something that accelerates you a great deal when you're dealing with things, and in particular with new or unexpected things in deep learning. At the same time, I think a lot of things can be intuited about with experiments, with like really simple data sets. For example, this you mentioned the double descent thing. The thing I'm thinking about is showing double descent for a set of two Gaussians, and that's it. And you have two Gaussians in 2D, and then you can see double descent. And you can hypothesize that deep learning models are just a complicated way of doing the same thing. And that's kind of the intuitions I like to have. And I'm really, and I think the visualization of things goes a long way. And so one thing about mathematics, it's cool and it gives you structure and it's incredibly important and it describes how the world works. For example, like this R value that defines whether we actually can beat COVID or not. And so, but at the same time, there's the danger that people use formulas to explain in great detail the bits that they know best, and they will skim over the bits where they don't know the formulas for. And that's kind of the thing you have to be wary of. Spending too much time on the things that are easy to explain with formulas. And so I'm definitely a person who knows the way around formulas, but I also avoid them if I have an alternative mean of communicating. And I certainly don't think most mathematicians think about formulas, and maybe there's a reason for that.
Mm-hmm. Great. Luca?
I had a friend, a person that I met a few years ago, and we interacted for a bit, and then we didn't interact for a while. And he's an engineer, is a great fluid dynamicist. And then he wanted to get into machine learning a bit, and he picked up the book. And one of the nice compliments is that he said, I finally found a book that speaks to an engineer. Because the way we trained ourselves to see things kind of influences the way you explain it to yourself, and then it influences the way you explain it to others. So I'm sure the book resonates with certain with people with a certain background, maybe less for people from another background. So formulas help to the point where, so it's like musical notation. Probably to really get into advanced stuff, you need to have a concise way to communicate hard concepts. Mm-hmm. That words would be inefficient, like common sense would be inefficient. So if you look at a complicated score, it would be impossible to just play it by ear, right? By heart. You really need, to grasp. Or if you're learning something like, I don't know, harmony for jazz, you need. There are some people who can do it, but the majority of people just have to, practice, and through practice and learning, using the right formal language, they can then achieve the moment where they can take that formal language, set it aside, because at that point your brain has built some kind of representation of things that just clicks. So the way to go from not having that representation to having it sometimes requires you to, forces you through that small hole of, notation and so on. So then to achieve a greater understanding of things. Mm-hmm. And I see mathematics, the notation, to be instrumental for that. I think that deep learning at the level we are explaining it in the book, which is not just, super entry level. We go into some depth, but it can be explained without requiring that. So then, of course, if you want to cast it in a more statistical or Bayesian setting, and then you get into that mindset that requires you a certain formalism. But from a purely, let's say, engineering perspective, knowing how things pretty much work doesn't require a heavy mathematical notation. Mm-hmm. But the intuition can be conveyed through description.
Mm-hmm. It's beautiful. Very good advertisement, Luca, because a lot of engineers are listening to the podcast, hopefully. And I mean, I have the book here, and it's more beautiful. I can do the same maybe with the background, but not as beautiful as Thomas does. But it's also very thick. Like if you want to look stuff up, I think it's written in an excellent way. I haven't gone through it completely, but from what I've seen, it's really, I think, a must-have, especially for engineers, as you mentioned. And thanks for mentioning this, that it's also for engineers, so that's a good one. Eli, do you want to continue?
I think that Thomas and Luca have definitely covered a lot of it. I just want to emphasize that I think that it really depends on what your goals are. If your goal is to, and by the way, Thomas, I don't disagree at all about your characterization of the lottery ticket hypothesis. But like if you're wanting to do that kind of fundamental research, being able to look at the work that other people have done in that fundamental research, being able to consume the papers that they've written, all of that makes a lot of sense. You're going to need to know mathematical notation and be comfortable consuming it. But if your goal is to get a system into production, almost certainly you don't want to be on the cutting edge. You want to be using proven techniques and stable techniques. And those, I think, can be expressed without needing an extensive mathematical notation, an extensive comfort with that, because again, that's more of an engineering problem.
Does anyone of you want to talk about the deployment issues, which is when I think about an autonomous vehicle, for example, I mean, you deploy it on the device per se, like on the embedded hardware, and also you have this kind of cloud-based topic where you deploy things on the cloud, for example, AWS or whatever. Where do you see the advantages and also disadvantages of using HPC systems or maybe embedded device technology? Who wants to go first and has his opinion on this?
Well, so I'll go first, and then the others will have the interesting bits. So I think really must be kind of up to the task, right? I mean, so we have some things where or in many, surprisingly many cases, we still want to have things like have the AI where the data happens. So for example, in the vehicle, or maybe also on the factory floor, it certainly makes sense to just have a device that works on its own. At the same time, there are many situations where maybe going in the cloud is the natural thing. For example, if you consider a mobile phone, obviously there's a lot of things that you can do on mobile phones now in terms of running models there. At the same time, mobile phones are almost always online. So maybe most of the things we do on the phone, we don't do on the phone because we couldn't potentially do them in the cloud. And then you have aspects like privacy, or maybe stuff like how much data transfer costs, and maybe also where you are at in the world that play a role. But so I think it strongly depends on what your site conditions are in terms of reliability, the amount of compute that you need. Also, if you can rely on a connection to somewhere else or not.
Mm-hmm. Yeah, especially when it comes to autonomous vehicles, like latencies plays a big role here as well. Anything else? Maybe Luca or Eli?
At Orobix, we do AI, for example, on the factory floor. And in those situations, there's no alternative. You need to go on the edge because there's no time. For example, when you are checking parts that are being produced, for example, and you have a model that scans for defects, and you need to give the answer in sometimes really, really quickly. There could be 40,000 or 70,000 pieces per hour being produced, and so there's really no time for a round trip on the cloud.
Mm-hmm.
And I think that is specific to that world, of course. I would say go on the cloud whenever you can, because the edge is has its own additional problems, from things that break to things that do not speak to other things anymore, to things that get too hot, and things that get smashed by something else. So there's a lot of real world situations that can happen there.
Mm-hmm.
But now more and more, even the big cloud providers are providing ways to control edge devices from the cloud. So I think we're entering an era where the edge is an extension of the cloud, and this is what we are doing at Orobix, basically these days, setting up technology to do that and using what cloud providers provide to do that. And I think it's a much better place than it used to be.
Mm-hmm. Excellent. Eli?
Well, so kind of a bit of a tangent. I think it's really interesting how we saw an incredible amount of consolidation on what model training looks like. kind of like boiled down to like GPUs and TPUs. And we're starting to sort of see a widening again where there's a lot of specialized hardware being produced for training situations. It doesn't feel to me like we've hit a point of consolidation on the deployment side of things. Like Luca was talking about, you've got stuff running on the factory floor. Like Thomas was talking about, you've got stuff running on mobile phones. Like the places where this stuff is getting deployed is so wide that we haven't had an era of consolidation in the first place. And part of me does not feel like we ever really will, because I don't think that we're going to reach a point and say, oh, well, this is the ideal way to deploy a model for all use cases. And I'm wondering if we are going to then have, in 5 years, a similar explosion of ways of deploying things so that it's even more complicated than now, or if we've already had that. I'm not quite sure how that's going to shape out, but I suspect we're never going to have a consolidation phase, just given how wildly different all of the use cases are.
Mm-hmm. I mean, when we're already making assumptions about the future, I have 2 questions left. So before we wrap things up, and the last part would of course be a more relaxed part, which is like, how is it writing a book? And then you can answer. But the one question before we jump to that is, where would you like to see AI going into the future? What kind of problem would you like to see solved? Whether it be healthcare or any other topic. Maybe Thomas, what would you like to see solved in 5, maybe 10 years?
Well, anything that's boring. And to be honest, I think this is where AI stuff really shines. This is both something positive and negative to say here. I think that we will automate a fair share of things that are currently like chores that people have to do, and hopefully it leads to people being able to do more fun things. At the same time, I think that there's I'm not one of these general AI believers, and so I would expect that kind of true thought is quite a way out yet.
Mm-hmm. But what, like assuming there will be an AGI system in 10 years, hypothetically, what would you ask it?
Leave me alone.
Okay.
Yeah.
Okay, that's also, let's see what it answers then. I would be quite curious what the system answers. Let's see. Luca, do you want to continue? What kind of problem would you like to have solved in 5 to 10 years from AI?
I think something that hasn't been really, well, maybe not explored, but would be, how do you compose systems? How do you build more complex system out of simpler systems in a way that is not just chaining things together. One other thing is how you take something that acts as a backbone and really specialize it on your case. I mean, there are many examples now out there, but I think there's a lot to do in this case. And composition is in the same setting. Like you take 2 things that have been trained on something a bit generalistic, and how you make them cooperate to quickly come to a solution. This is from people that do my job. From a citizen and a dad, and I really hope. I mean, the problem is not the AGI will kill us all. Is that we'll be able to kill ourselves with with a sharper knife, the way we've always done. Only that now we can reach bigger scales. So I think the new generations will have to be very disciplined and robust to the attacks of exploiting the bugs that we have in our heads, as the news shows. There are very effective ways to do that, and history of mankind has been full of people that could exploit those bugs to get approval and people doing crazy things for you. But today, I think it's very evident that computers can help us in doing that, and so I think I hope the new generations will be able to use AI to tell the truth from what is not true. And so I think it's really important that people get an education and are not just passive pawns, scrolling on their phone. But I think the young generations are very lively in this regard. Not everybody, but I see. I'm quite impressed by what I see. So, as the AI, which is a tool in the hands of people that might or might not be well-intentioned, gets smarter, I hope the same will be true for the 16, 18, 20 years old, that will get smarter as well. Yeah. And I think spreading education is one of the ways we can help this process.
Excellent. Eli?
I'm going to echo a point originally made by Andrew Trask, fellow Manning author and one of the visionaries at OpenMind. And he makes the point that we spend an incredible amount of computational resources trying to solve ImageNet. And while the underlying fundamental research that happens there is obviously important, the problem that we're solving is like figuring out, well, what kind of mushroom is that? What kind of terrier is that dog? And fundamentally, those problems, while interesting, they're not crucial. And he posits that we should instead have all of our standard benchmarks for image processing routines being, well, can we improve cancer diagnosis? Here's a data set of biopsies. Can we eke out an additional 0.1% correctly identifying malignant tumors from benign growths, or just a whole host of those sorts of things, so that when we are spending, thousands and thousands of CPU days to train the latest model to find out if your activation function is the greatest, you are incidentally also making medical diagnoses better. I think that if we can make that shift, so that instead of thinking about, okay, well, here's the data set that we're going to use, and we'll just keep using that data set kind of without even really thinking about it. If we can instead say, you know what, we're going to make sure that the data sets that we're using are making the world a better place as we eke out that 0.1% improvement. I think that having that kind of attitude about being conscientious about where we spend our compute resources and how we spend our time, I think that is going to be, I hope it happens. And if it does, I think it'll be a huge societal benefit. So I highly recommend that everyone watch Andrew Trask's talk. He's given several good ones at the PyTorch Developer Conference, PyTorch Dev Day. Anyway, when you're done listening to this podcast, now you've got another to listen to.
Perfectly put. I like it. To wrap the session up, I really liked talking to you guys about different concepts and ideas. Maybe a relaxed topic now. How is it writing a book? Maybe Thomas, if you want to start, how is it for you? How was it for you writing a book? Which isn't thin, to be honest, I have to say. It's like a thick book.
No. Eli will start on this.
Okay, Eli, if you want.
Yeah. So, my personal journey to writing a book was kind of odd. I was working on the Kaggle Lung Cancer Detection Challenge in January 2017. PyTorch 0.1 came out, and I ended up submitting a couple like minor bug fixes and a documentation change back to the PyTorch project as when I bumped into stuff. And then, kind of moved on, did some other stuff. And then that summer, like 6 months later, I get a random email from the publisher saying, "Hey, would you be interested in writing a book?" I'm like, I just taught myself this stuff like 6 months ago. You must have the wrong person. But I took the call because, why not? And I told them, I was like, I don't think I've got the time to pull this off. And they're like, well, how about a co-author? And so they introduced Luca and I, and we clicked. And the way I like to say it is we decided, well, I've got no time and, he's got no time, and 2 times 0 is enough time to write a book, right? I found it an intensely rewarding experience, but I was right. I did not have time. and so the book ended up taking far longer than we wanted. And as I alluded to earlier, when Thomas joined later on, it was crucial because it really allowed us to kind of push the book over the finish line, drag it over the finish line. And so he did an incredible job helping us out. I'm not sure if I would do it again.
Dishonest. I like it.
I'm glad I did it once, but twice is a lot. So I'll pass the torch on then.
Luca, would you do it again?
I don't know. No, not now. I've got a bit too many things going. To me, it's been an experience that I didn't anticipate. Like they say write drunk, edit sober. Yeah, I kind of missed the sober part, but I really enjoyed the drunk part. Not that I was drunk. But maybe not all the time. But I think the writing long form, in which you start writing, you don't know. Yeah, you have an idea for what you're gonna write, like about, but you don't have a fine-grained idea of how things will happen while you're writing, and find yourself in that writing process where you're creating something and then your next paragraph is based on what your past paragraph kind of came out. It's a very, encoder, decoder type of thing, right? Yeah. So it was nice. Like the long form writing is something I never experienced, and I really enjoyed it. And some of the stuff I wrote, if I rewrote it the next day, it wouldn't be the same as maybe as the previous day. Mm-hmm. So it's really nice to capture that process on paper. There's a lot of randomness and serendipitousness in the whole thing. Mm-hmm. So it was nice, very nice.
I want to second that I found the writing process much more palatable than the editing process.
Oh, yeah.
But I think that the editing process was far more crucial to the book being any good.
Yeah, that's absolutely crucial. Yeah, that's true.
And I do want to point out to anyone that hasn't gone through the experience, having a professional copy editor go over your work is incredibly humbling.
I think this is great advice. If Thomas doesn't want to add too much to this kind of book topic, maybe if you want, you can do so, but we're also running out of time.
Yeah, I'll keep it short. So as I heard, I joined the book when the kind of the first few chapters were put up on the PyTorch website. And so I really liked the style, and it was an easy decision. Contrary to the two guys, I'm not that worn out, and I absolutely want to write another book, maybe either one that takes out all deep learning or one that really goes into theory, one or the other. I think it was a really interesting experience to work with a professional publisher. And obviously the copy editing process and the editing process in general, I took away a whole lot for it, even for my own writing that I do for my blog or something without a publisher. And so both working with Eli and Luca and working with Francis and Brian and the other people at Manning, Katie, was a really, really great experience.
Mm-hmm. Thanks for giving us insights into what it's like to write a book. So with that being said, guys, thank you so much. The session took longer than expected, unfortunately, or fortunately, however you want to see it. And as always, we'll put the links of everything that's relevant, like your social media profiles. Of course, the book with a discount code, so people can save a few bucks on it, in the description. And as always, we'll give away at least 5 copies, ebooks of the Deep Learning with PyTorch book. With that being said, again, thank you so much, guys, and hopefully we'll be in touch in the future.
Thank you for having us.
Sure.
Thanks a lot.
Yeah, thanks. It was an honor and a pleasure to be with you here tonight.
Thank you so much.
And Thomas always says it better, so yeah.
Yeah,
so much,
when
guys.
it's the soft subjects, I'm your person.
Thank you so much, guys. Take care.
Bye.
Okay,
Thank you.
see you.
Bye.
Bye-bye.